In Mod 14, we are going to look at polar equations and polar numbers. And so we're going to start out with some basics on just how you graph polar equations. On our first equation, we have r equals 3. What you need to remember is that r stands for radius. So we want to draw everywhere on this circular looking graph, this is a polar equation graph, where the radius is 3. So if you count out from the center, 1, 2, 3, that means this is a radius of 3, and this is a radius of 3, and this is a radius of 3, and this is a radius of 3. So everywhere that has a radius of 3 is following this circle that is 3 lines out from the center. So that's how you graph anything that is r equals. It's always going to be a circle because it's a radius of 3. What if you have one that the equation says theta equals 3 pi over 4? Now remember that theta is an angle measure. So you are going to go to the angle of 3 pi over 4, and then you are going to trace that line through 3 pi over 4 and then all the way through to the opposite quadrant. And so that is the equation of the angle 3 pi over 4. On our next example, we are going to look at the equation of r times cosine theta equals 3. What helps me on this is thinking about what we defined the cosine as. We defined the cosine as the x coordinate. So this is the same as if we were drawing a line that says x equals 3. In the rectangular system, an x equals is a vertical line. It is also a vertical line in the polar system. But you go out to the third line from the center. So we go out 1, 2, 3 lines from the center and then draw a vertical line at that point. So now, if we have one that is r sine of theta equals -1, here we have to think about how we defined the sine. We defined the sine as the y-coordinate. In the rectangular system, if you draw a line that is y equals, it's horizontal. So in the polar system, when you are graphing a sine, which is y, you also draw a horizontal line. Through -1, the -1 is that first circle out from the center, and you draw a horizontal line through there. The next thing we have to be able to graph is just a complex or imaginary number. So what if we are going to graph something like 4 plus I? The coordinate system looks very similar to what we've already used all along in graphing points. But in this case, the x-coordinate is for the real number, which is what you are used to seeing. The 4 is the real part. The y-axis is for the imaginary part, so it's whatever is with the I. So because this is a positive 4, we are going to go right 4 and up 1 because it's 1i. So that is point A. If we have point B being -2 plus 5i, the real part is -2. So we are going to go left 2. The imaginary part is 5i. So we're going to go up 5 I. And so there is point B. Point C is 6 minus 2I. So for the real part, we are going to go right 6. For the imaginary part, we are going to go down 2. And there is point C. The next thing we're going to look at is converting a number from polar form into rectangular or complex form. Polar form will still have I in it, but it will have sine and cosine in it instead of just numbers. So in order to convert from polar form into complex form, it's not too bad. You got to do callback on your unit circle again. You leave the 2 out front right now. We know from the unit circle that the cosine of 300 degrees is 1/2 plus I times, we know that the sine of 300 degrees is negative square root of 3 over 2. So then to finish this, we have to actually distribute our 2. If we do that, 2 times 1/2 is 1 plus 2 times negative square root of 3 over 2 is just the negative square root of 3 times I. Now we are back in complex or rectangular form where we have the real part and the imaginary part. So we are done. On example B, our problem is 10 times the cosine of 3 pi over 4 plus I sine 3 pi over 4. Notice that on these numbers, the angle stays the same, and it's always cosine written first plus I times sine of the angle. So just like we did before, we're going to leave the 10 on the front. We're going to replace the cosine of 3 pi over 4 with what it's equal to, which is negative square root of 2 over 2. Plus, keep the I. The sine of 3 pi over 4 is positive square root of 2 over 2. Again, we are going to distribute the 10 to finish this. 10 times the negative square root of 2 over 2 is going to give me negative 5 square root of 2 plus, we keep the I. 10 times positive square root of 2 is positive 5 square root of 2. You can write the last term this way. You could write it 5I square root of 2, or you could write it as 5 square root of 2 times I. Any of those are the same thing. As long as you've got all three parts, remember that multiplication can be written in any order, so any of those would be correct. On example C, they wrote the problem a little differently. This is the shorthand version of writing a polar number. We put this cis in there. So what you need to recognize is that the C stands for cosine. So it's cosine. The angle is 150 degrees. It's always plus. The I is for the imaginary I, and then the S stands for sine of the angle we are given, 150 degrees. Those two expressions mean exactly the same thing. So now we're going to substitute what we know, cosine 150 to equal, which is negative square root of 3 over 2, plus, keep your I, the sine of 150 is positive 1/2, and then distribute your 3. So you're going to get negative 3 square root of 3 over 2 plus 3 times 1/2 is 3/2. Usually if you just have a number and the number goes in front of the I. So one more of the cis version, just to get you used to it. If we have the square root of 2 cis of 225 degrees. Remember what that is. The square root of 2 stays out front. C is for cosine of the angle. The I stands for the imaginary I. S stands for sine of the angle. So we're going to have the square root of 2 times cosine of 225 is negative square root of 2 over 2 plus I times the sine of 225 is also negative square root of 2 over 2. So if we take that square root of 2 out front and distribute it, we are going to get negative square root of 4 over 2 plus I times negative square root of 4 over 2. Well, the square root of 4 is 2, so we've got negative 2 over 2 plus I times negative 2 over 2. So we've got negative 1 minus 1. I just took that negative 1 and put it out front times I. The next thing we want to do is convert numbers from imaginary form into trigonometric or polar form. What you have to remember is that these two forms of the number are equivalent to each other. So what that's telling us, the reason I need this is because I need to know where the x and the y are. X is the real part of the number and the I is the coefficient in the imaginary part. The other thing we need to remember is how we find R. R is always the radius or the hypotenuse in the triangle. How do you find a hypotenuse? You do the square root of x squared plus y squared. If you think about doing the Pythagorean theorem, that's always what you're doing. You do x squared plus y squared equals r squared. And so if we just solve that for r, you get r equals the square root of x squared plus y squared. Another piece of this that we are going to think about is the fact that we have an x and a y. And if we have an x and a y, we can find the tangent. The tangent is always y over x. So we're going to use that relationship to help us figure out what angle we need. So let's just jump in on one of these. We are going to start by converting the number 1 plus I times the square root of 3 from complex form into trig form. Well, because the real part is 1, that is the x. The coefficient with the I is the square root of 3, so that is the y. In order to find r, we're going to do the square root of x squared plus y squared. Well, that's going to give us the square root of 1 plus 3. Square root of 4 is 2. So now we know r. The other thing we want to think about is tangent. The angle that we are looking for has a tangent of y over x, or square root of 3 over 1. There's more than one angle that has that tangent. So what we have to do is go back to our original number. This is why we had to learn where they graph. Because the real part is +1, we would go right 1, and the imaginary part is also positive, we would go up the square root of 3. Well, if you go right and up, that puts you in quadrant 1. So now that I know I'm in quadrant 1, I have to go back to this tangent that I was looking at. What angle in quadrant 1 has a tangent of the square root of 3 over 1? Well, that gives me a theta of pi over 3. So now that I know my r and I know my theta, I am ready to actually write polar form. Polar form always starts with the r. Our r is 2. Then you open the parentheses. It always has cosine first of the angle that you figured out. We figured our angle to be pi over 3 plus I, and then sine of the angle that we figured, pi over 3. Or if you want to, you can write 2 cis pi over 3. So let's look at another one. Let's look at 3 minus 3i. We know that our x is the first number, our y is the coefficient of the I, so it's -3. To find our r, we're going to do the square root of 3 squared plus -3 squared, which is going to give us the square root of 9 plus 9, which is the square root of 18, and then that simplifies to be 3 square root of 2. So now we know the x, y, and r. We need to figure out tangent. Tangent of our angle is going to be the y value, -3, over the x value, +3, which is -1. Now we know that tangent is -1, so we have to think about the fact that tangent is negative in quadrant 2 and in quadrant 4. So what we have to do is go back and look at our original number. Which quadrant did it fall? Well, if we went right 3 and then down 3, that puts you in quadrant 4. So that means that the theta that we are looking for has to be in quadrant 4. So in quadrant 4, what angle has a tangent of -1? That angle is 7 pi over 4. So now we know r, we know our theta, we are ready to actually write polar form. Polar form starts with r, 3 square root of 2, and then we always have cosine of the angle we figured out plus I sine of the angle we figured out. Or if you want to, you can write this as 3 square root of 2 cis of 7 pi over 4. Either one is fine. For our last example of this, we are going to look at the number that is 4i. That is still a complex number because it has I in it. Well, let's think about that. Could be written as 0 plus 4i. So if you think about that, The real term being 0 means I'm going to stay on the axis. So this is just going to be on the positive y-axis. So our x is 0, our y is 4. To do r, we're going to do the square root of 0 squared plus 4 squared, which gives me the square root of 16, which is 4. The tangent, you can still do that. You get the tangent of theta being y over 0, which is undefined. So we have to think about, where is tangent undefined? It is undefined on the y-axis, and it could be two different angles on the y-axis. If we were on the positive y-axis, that means that our theta on positive y-axis is pi over 2. So r is 4, theta is pi over 2. So our polar version is 4 times cosine pi over 2 plus I sine of pi over 2. In order to multiply two polar numbers, you multiply the r's that are out front. Then you add the angles. You keep the cosine and the sine in the same position, but you add the angles. Our first example of this, we are going to take 3 times the cosine of 45 plus I sine of 45 times 2 cosine of 135 times I sine of 135. So in order to do this multiplication, we take the two r's times each other, 3 times 2. Then we do the cosine of the two angles added, 45 plus 135, plus I times the sine of the two angles added, 45 plus 135. Well, 3 times 2 is 6. Cosine of 45 plus 135 is 180 plus I sine of 180. And that is your answer. You are done. On our second example, we have 4 cis of 120 times 5 cis of 30. Even though it's written in the other version of the trigonometric number, it's not any different in process. The r's are 4 and 5, so we're going to multiply 4 times 5. We're going to have the cosine of the two angles added, 120 plus 30, plus I times the sine of 120 plus 30. That means we now wind up with 20 cis of 150 degrees. As you might expect, doing the quotient or division of polar numbers is going to be the reverse of multiplication. So you are going to divide the r's, take r1 divided by r2, and then instead of adding the angles, you are now going to subtract the angles. For our first example of division, we want to divide these two polar numbers. So we want to take the r of the first number, 10, divided by the r of the second number, 5. Now, inside our brackets, we are going to have cosine of the first angle, negative 60, minus the second angle, 150, plus I times the sine of the first angle, negative 60 minus 150. So now simplifying, 10 divided by 5 is 2. And then we are going to have the cosine of negative 210 plus I times the sine of negative 210. And we are done. On our second example, we take the r's divided by each other. So we take 27, the first r, divided by 9, the second r. We will have cosine of the first angle, 45, minus the second angle, negative 180, plus I times the sine of 45 minus negative 180. If we work that, 27 divided by 9 gives us 3. Cosine 45 plus 180 gives us 225 plus I sine of 225, which you can write as 3 cis of 225.